Network Access Control NAC and Endpoint Security. Welcome to this lesson on Network Access Control, NAC and Endpoint Security. In today's IT environments, securing access to networks and endpoints is critical. Organizations must ensure that only authorized users and devices can connect to their networks while preventing threats from spreading across systems. Network Access Control, NAC, enforces security policies at the entry point, while Endpoint Security protects individual devices from malware, unauthorized access, and data breaches. In this lesson, we will explore how NAC and Endpoint Security work, their risks, and best practices for securing enterprise environments. Let's get started. Network Access Control is a security framework that restricts unauthorized users and devices from accessing a network. NAC ensures that only compliant, authenticated, and trusted endpoints, such as computers, smartphones, and IoT devices, are allowed to connect. Think of NAC like a security checkpoint at an airport. Only travelers with valid boarding passes and proper identification are allowed through, while those without authorization are denied entry. Similarly, NAC enforces strict authentication before allowing a device or user onto a corporate network. For example, a university implementing NAC can prevent students from connecting personal laptops to administrative networks, reducing the risk of malware infections and data leaks. Here's how to implement NAC effectively. Use role-based access controls RBAC to restrict user permissions based on job roles. Enforce device compliance checks before granting network access. Integrate NAC with Identity and Access Management, IAM, for stronger authentication. Endpoint security refers to the protection of individual devices, such as laptops, mobile phones, servers, and IoT devices, against cyber threats. Since endpoints are common attack targets, securing them is essential for preventing malware infections, data breaches, and unauthorized access. Modern endpoint security solutions go beyond traditional antivirus programs. They include Next-Generation Endpoint Protection, EPP, Endpoint Detection and Response, EDR, and Zero Trust policies to safeguard systems against evolving threats. For example, a corporate office implementing endpoint security can prevent employees from installing unauthorized applications that might introduce vulnerabilities into the network. Here's how to strengthen endpoint security. Use multi-factor authentication for all endpoint logins. Deploy endpoint detection and response, EDR solutions to detect and contain threats. Enforce patch management policies to keep operating systems and software updated. While NAC and Endpoint Security enhance network protection, they also introduce challenges that organizations must address. First, BYOD, bring your own device risks. Employees using personal devices may introduce malware or bypass security policies, exposing the network to threats. Second, outdated software and weak configurations. Devices running outdated operating systems or unpatched applications can become easy targets for cybercriminals. Third, lack of visibility. Without proper monitoring, IT teams may struggle to detect unauthorized devices or compromised endpoints. For example, a remote employee using an unpatched laptop to access corporate resources could unknowingly introduce ransomware into the network. Here's how to mitigate security risks in NAC and Endpoint Security. Implement strict BYOD policies that require device compliance before accessing corporate networks. Regularly audit endpoints to identify and fix outdated software or misconfigurations. Use network segmentation to isolate high-risk devices from sensitive systems. To strengthen network security, organizations must enforce strict access controls and authentication mechanisms. Zero Trust Network Access, ZTNA, is a security model that assumes no device or user should be trusted by default. Instead, every access request is verified continuously. For example, instead of automatically granting access to employees inside a corporate office, Zero Trust requires authentication for each resource they attempt to access. Another key strategy is integrating NAC with multi-factor authentication, MFA, to ensure users provide multiple forms of verification before gaining access. For example, A healthcare provider using MFA and NAC can prevent unauthorized devices from connecting to electronic health record EHR systems. Here's how to secure network access and authentication. Adopt a zero-trust security model to limit access based on real-time risk assessments. Require multi-factor authentication for all remote and privileged access. Integrate biometric authentication for enhanced security in high-risk environments. Let's look at a real-world example of how a large enterprise secured its network using NAC and Endpoint Security. A global technology company struggled with unauthorized devices connecting to its internal network, increasing the risk of cyber attacks. To address this issue, they implemented a comprehensive NAC solution that enforced strict access policies and endpoint compliance checks. Additionally, they deployed an endpoint security platform that included next-gen antivirus, behavior-based threat detection, and automated patch management. As a result, the company reduced unauthorized access incidents by 80% and prevented multiple malware outbreaks, strengthening overall network security. Here's how to implement enterprise-level NAC and endpoint security. Use automated compliance checks to verify devices before granting network access. Deploy AI-driven endpoint security solutions to detect and block advanced threats. Continuously train employees on cybersecurity best practices to prevent human error. Now, let's summarize what we've learned about network access control, NAC, and endpoint security. NAC enforces access control policies to ensure only authorized devices and users connect to the network. Endpoint security protects individual devices from malware, unauthorized access, and data breaches. Security risks include BOD challenges, outdated software, and lack of network visibility. Zero-trust security models enhance access control by requiring continuous authentication. AI-driven monitoring, automated compliance checks, and employee cybersecurity training improve network security. By implementing these best practices, organizations can secure network access points, protect sensitive data, and prevent cyber threats before they escalate. This concludes our module on network access control, NAC, and endpoint security.